The next part is the heart is actually divided into 4 parts. And we're going to draw this fairly large, just like this. Now I'm drawing the heart as a circle, but we know it's not. It's actually a very complex organ that has a very unusual shape. But we know that there's a left side of the heart and a right side of the heart. And that's actually divided with a wall straight down the middle. Okay? This wall separates blood from both sides. It actually separates electrical signals from both sides. And that's an important concept to get. There's a left side and a right side, and they can almost be completely separate. There's actually a top and a bottom as well. The top part are called atria, in plural, right? But one of them is called an atrium. Atria, if we talk about both of them, atria, atrium, if we talk about one of them. So this is the left atrium, and often we just write this LA. This is the right atrium, and often we just write RA. The bottom parts, of course, are ventricles. Or ventricle, if it's just one of them. Obviously, this is the left ventricle, and this is the right ventricle. Now, there's 2 concepts here. The first is the heart is a muscle that's pushing blood around. And that we're not going to measure so much in this class, although we will talk about vital signs and blood pressure and heart rate. But what we're really looking at is the electrical signals that are controlling this pump. Okay? I'm in a room right now that's lit with some overhead lights. You can't see them in the shot, I'm sure. The electricity is what's lighting up the lights. But of course, there's a mechanical thing, the bulb itself. In this case, the heart is the mechanical thing, or the bulb, and the blood is the light, and then last but not least is the electricity that we're flipping a switch. And what we talk about in EKGs is this electricity that's telling these things to contract when they do. And that's the tricky part. First, to have a good pulse, to have a good heart rate, we need a nice, even, rhythmic contraction of the heart, which is to say the top part of the heart's beat and the bottom parts of it. The top parts of the heart beat, then the bottom beat. Now, if you've ever listened to someone's heart with a stethoscope, you hear lub-dub, lub-dub, lub-dub. 2 beats for 1 heartbeat. What you're hearing is atria, ventricle, atria, ventricle. And that has to happen in order. We have to have the atrias fire and contract and squeeze, then the ventricles contract and fire and squeeze. Because what's happening is blood's coming into the top part of the heart, it gets squeezed into the bottom part of the heart, and then goes back out again. This happens simultaneously on both sides of the heart, just like that. Okay? Top squeezes to the bottom, squeezes out. Top squeezes to the bottom, squeezes out. Now, each side of the heart is actually doing something very unique. On the right side of the heart, we're pumping blood over to the lungs. The left side of the heart is pumping blood out to the body. Top pumps to the bottom, pumps out. Here it's pumping over the lungs, where it's gathering oxygen, of course, and it's getting rid of carbon dioxide. All right? Here we're putting oxygen out to the body and picking up carbon dioxide. Follow that? Top to the bottom, out. Lungs pick up oxygen, drop off carbon dioxide. Body drops off oxygen, picks up carbon dioxide. That's all that's happening. It's a double-sided pump with 2 circular motions that's making that happen. When it comes back from the lungs, this actually starts at the top of the left side here, and when it's done dropping blood off out of the body, it starts back up here. Now that's going to look a little weird, and there's tons of animations, and I've linked them to in the program that might show you this a bunch of different ways. Being able to trace the blood through the system is important. Now, I won't kid you. You could take an EKG and never completely understand that. But do you want to be a healthcare provider and part of the team to be the one person on the team who doesn't understand it? You want to take a minute and figure this out. And there's lots of ways you can do this. My simple drawing here is a good beginning. Right atria pumps to the right ventricle, pumps to the lungs where it picks up oxygen, drops off carbon dioxide, returns to the left atria where it's pumped to the left ventricle, goes out to the body. That's the top of your head to the tip of your toes. The blood returns back into the right atrium again. And sure, there's a lot of blood vessel names and things that matter here, but that's the next chapter.